market or semiconductor industry, it's aging, is very old, and undergrads are not excited to be part of it. So, and I think a way to fix this is to bring startups back to the semiconductor industry, which you don't see a lot. So a little bit about me. I have a PhD from Georgia Tech. I'm a microchip designer by training. I spent most of my time in academia and in some government research labs. And one thing that I always like to say is that I have no industry experience. I have zero industry experience. And that's an important point that I like to make. Besides being the CEO of Falcon for the past 3 years. So what is Falcon? I'm going to tell you guys a little bit about Falcon and what we do. So we want to unlock the potential of wireless communication through semiconductor innovation. So our main goal is to increase energy efficiency of semiconductor products for wireless communication, SATCOM, radar, and some other cool applications. This is a little bit of the history of the company. We started back in 2021. We were incubated by UC Berkeley. They have an accelerator program called Skylake, which anybody that's interested about entrepreneurship and starting your own startup, I encourage you to look them up. A few years later, 2022, we got patents and we got our first round of funding. Then 2023, we got our second round of funding. Then we started building the team and the infrastructure to design the products and testing and verifying, and also building the relationship with the semiconductor assembly houses, which is really important. We started building our office and design center in Atlanta, so we're located in Midtown Atlanta. We have a design center there, and also a testing and verification facility as well. 2024, we started developing, measuring the products, packaged products that we developed for the previous 2 years, and we're getting world record efficiencies. Recently, a month and a half ago, we closed our third funding round. Currently, we're engaged in commercial engagements, if you will. So we're actively working with customers to deploy products. So in terms of what we do and who we are, so we're a fabless semiconductor company. That means that we build microchips and we partner with foundries such as Global Foundries and Northrop Grumman for the manufacturing. We also work with assembly houses for the packaging and some upstreaming and sometimes space qualification as well. We offer full turnkey design services, meaning that we can go from technical specifications all the way to package products and eval boards. Our main expertise, we're PA designers, RF millimeter wave, that's our expertise. We also work on LNAs, switches, front-end modules, and beamforming ICs. In terms of testing and verification, we have a state-of-the-art in-house testing facility, thanks to our friends from Keysight. We can do everything from DC to 150 gigahertz in terms of CW modulation, temperature, across different temperatures. And again, packaging, we do some prototyping packaging in-house. So we do typical wire bonding and QFN packages and all that, but for higher volume, we go outside with different assembly houses. This is a little bit more about who we are and what's the Falcon advantage. That's what we like to say. So one of the things is that we're partners with a lot of the foundries. So we're signed a partnership with Global Foundries. So basically we're what's called an IP ecosystem partner. So we're building and designing a lot of the reference designs for that are used in different processes in Global Foundries. We also have unique IP that we've developed. We've been doing research on power amplification for the past 12 years as a academic research lab, and now as a company. So we're developing really cool IP. And a lot of us are from Georgia Tech, all of them. One of the main things that I wanted to say, and I think somebody mentioned it before, is that it's really easy to design one and measure one in the lab, right? So and write a paper and be excited about. But in the past 2.5 years, what we focused was how can we take the IP that was developed at the university and then scale that and mass produce it, right? Volume produce it. So I think we learned a lot in terms of execution and supply chain management and how to create designs that are reliable and robust, and you can use them for 10 years and won't explode. So there was a lot of learning that we have to do, and we have to bring team members that have the abilities to help us do that. So that's kind of the pictures that I'm showing. Kind of you go from a university project to volume production, and then to an eval board with a package chip that you can start sampling customers. And that picture right there, it's one of our great PA designers. He's also our model for all the pictures, and that's our testing lab as well. This is some of the pictures of the facilities. We've been here, I would say, 9 months now. So as I mentioned, design center and also our testing facilities as well. This is the team, and we're growing. We're actually hiring right now. So for you guys that are interested in the semiconductor world, I'll encourage you to apply, to go to our website. In terms of our team composition, we're kind of a mix between PhDs and industry veterans, and I think that's a great mix of people to have whenever you're working on a startup and developing new technology. All right, so I'm going to talk a little bit about what is the problem that we're trying to solve, so you kind of have visibility of kind of the level of technical, the technical stuff that we're working on. So we're mainly working on power amplifiers. Probably all of you know what is a PA. It's the device that goes before the antenna, and as the name implies, it amplifies the signal. So from a very small kind of analog signal to a very large RF signal. As I mentioned before, semiconductor industry, I think because of the lack of startups, there's not a lot of innovation on the design front. And if you look at power amplifiers, we've been using the same type of architecture for the past 90 years. This is creating a lot of energy efficiency constraints, and for modern systems, the current architectures are not going to be sufficient for us to be able to deploy satellite systems and radar systems and so on. This is a picture that I love showing. This is the workhorse of wireless communication. It's a type of amplifier that, if you're in the RF world, pretty much you use or have used or, it's currently deployed. So I think it was first published in the 1930s. So you have an idea of how much we're innovating in the power amplifier semiconductor design world. So there's a lot of opportunities to innovate, and that's kind of, some of the, my main topic of this talk is to encourage people to look for opportunities and ways that you can innovate. So how are we solving this? So we came up with a new power amplifier architecture that is called a dual track PA. Why is it better? Well, in summary, we get better energy efficiency, higher power density, and also larger bandwidth, which translates to higher data rates and so on and so forth. So far we have 4 patents. I need to update this, and we continue to keep applying to more patents, and so far we've been great at getting patents approved. So that kind of speaks to the level of innovation and excitement around the architectures that we're building. I'll go through this really quick. I know it's late, but this is only 2 slides, I promise, so don't fall asleep. So in terms of energy efficiency, what is the innovation? In summary, what we did is that we artificially decrease the knee voltage of the transistor. And if you do this very careful, by you can build a theory, also design it and test it, you can demonstrate that drain efficiency drastically increase. This is work that we did back at Georgia Tech. Again, we spent many years working on this. So this is how it looks. That's a transistor. And basically, usually people see a transistor as a 2-terminal device. What we figured out is that if you use a transistor as a 3-terminal device and don't make an oscillator, you can make a really efficient power amplifier. And that's the core idea behind the architecture. And then, this is to show you that simple idea. So as we start driving the source and gate of the transistor at a specific phase difference and amplitude difference between the two, you can increase the drain efficiency and the power density, right? And then you take this idea and spend 10 years working on it, and then you have a startup. So I'm going to show a little bit of the measurements that we've done and the products that we've developed, so you can see kind of the level of innovation that we're working with. This is some of our automated setup that we have from Keysight. This is the one where we're testing the power amplifiers, efficiency, power, bandwidth, and frequency response, as well as modulation. So this is an example of the technology that we have. So this is a two-stage millimeter wave PA, center frequency around 20 gigahertz. We're getting efficiencies around 52%, which is super exciting for us. This is developing GlobalFoundries 45 RFSOI process. This is another example. This is a 39 gig, same process, and we're getting around 45% PA. This is a more mature product that right now we're sampling to customers together with the evaluation eval board, and it's fully packaged. Now around this is for KU band SATCOM applications. For this example, we're also using GlobalFoundries. We're getting efficiencies close to 50%. Now, so in terms of why people care about efficiency, why people care about having better power amplifiers, and this is just to give you visibility that for startups, one of the main things that you also have to focus is on the business development, the market, and ultimately how you make money with the technology that you have. The way that we like to break it down is between markets, so Wi-Fi, infrastructure, wearables, and defense. And anywhere you see it, energy efficiency translates to thermal management. Thermal management, whenever you're developing systems, let's say satellite systems in space, thermal management is extremely important since you don't have air in space to get rid of it. So it becomes kind of a bottleneck for satellite designers. In terms of infrastructure, cell phone towers, even though they're connected to the grid, the electricity cost is super high for network operators. So, if you think about it, that's $120 billion is paid in an electricity bill to support the infrastructure or the telecommunication infrastructure. So an increase in efficiency, you can reduce the operational expenses of your network. And then with wearables and defense, there's a lot of buzz, if you will, around defense tech and new defense systems, high energy systems, radar systems, and the main bottleneck for those is, again, energy efficiency and thermal management. So across the board, we're seeing a lot of what our technology can do for these different markets, and it's very exciting for us. So in terms, I'll pass this one. So I'll tell you a little bit of things that we've learned for the past 3.5 years that we've been doing the startup. And the slides that I presented previously is just to show you kind of an overall, give you visibility on kind of what we're working on at the business development level, technology level, and also a little bit of the venture capital funding and related, all that's related to how you get capital to start your startup, right? So this is a few of the questions that I've come up with after talking to a lot of people and then kind of asking me specific questions. So instead of where do you start or how do you start your journey, for those that are interested about entrepreneurship, I would suggest go to accelerators or business incubators. Usually schools are attached, or some schools have accelerators that will give you initial funding or angel checks where you can start, to build your company. Use your university network. Professors, some professors have successfully funded companies. So I would encourage you to talk to them, and also entrepreneurs in your area. There's a lot of people, in this area or any city that you are that are successful entrepreneurs. And in terms of how you get the most out of your network, my advice is create real relationships and mentorship relationships, and see them as mentors and guides for for your journey. And that could apply to entrepreneurship, or that could apply to the job that you're looking to get, and whatever it is that you choose as your next step in your career. We've been really lucky that we successfully got a team together that we really love and love working with, and I feel super lucky to have the team that I have. But in terms of how you find a co-founder, how you create a team that can support your vision and your dream, I would say you're in the best place to meet people and the best place to meet engineers. So go out there, take classes related to entrepreneurship, sign up to work on projects outside class and things of that sort, where you can kind of use your skills to build a project that it's not related to a class. I think that's a good way to meet a co-founder or somebody that in the future you can bring to your team. I'd say that at Falcon, I've hired a lot of the people that were in the PhD program with me. I think that's the best way to interview people. Just get to know them outside school or work. So it's really hard to do a startup. It's one of the most incredibly difficult things to do. There's not a straight path that anybody could tell you how to do it, right? But I would say, I always say, if you want to become an entrepreneur and you need encouragement, don't do it. All entrepreneurs don't need encouragement to follow the vision and the dream of what they want to build in the technology. And if you choose to do it, know that it's going to be extremely difficult. So in terms of how do you encourage people to keep working on that difficult project, what we do at Falcon is that every little win that we have, we celebrate it. It's important to celebrate every little achievement, no matter how little it is, and be ready to work 80 hours a week. That's the reality of startups. Your competitors are working probably harder, so I would say that. In terms of what to expect, I would say have fun. Find something that you really enjoy and love and that you're passionate about. And if you're lucky to find that, I think it's going to be a very fun journey for you. And again, it doesn't apply to building a company or entrepreneurship, but it could be for the next job that you're going to do after you leave school. So make sure that you find something that you really like and that you enjoy, and be ready to have fun. Thank you. I think that's all that I have for you guys. And you guys have any questions?
All right. Does anyone have any questions?
We are hiring.
So, great presentation. I was just wondering, what motivated you to starting your own business, and then that too within semiconductors, and what kind of advice can you give to those that maybe want to pursue a PhD or a master's or create their own company?
So what the first question is, what motivated me to?
Yeah, so what motivated you to start your own company, and then that too within why semiconductors?
I started applying for jobs and I hated it. So that's the reality. I didn't like, I love semiconductors. I love design. I'm a design. My nature is to be a designer. It's in my nature, but I do mean it when I say that the semiconductor industry is a very old and aging industry, and there is not a lot of innovation on the design side, especially for the RF value chain. And if you go to any school and you ask undergrads and even grad students that are working on RF design and semiconductors, they're not excited about joining the industry because it's not an exciting industry. That's the reality. So I saw it as an opportunity to create something exciting that people could join and have a mission of how are we gonna make this, how can we innovate in the semiconductor space and make it exciting again? So that's kind of why I did it.
I have a question. So when you were kind of doing your PhD and all, did you have like internships and all of that, or were you mainly focused on like research and all of that? And then kind of like a follow-up, for someone who might be interested in doing research and like kind of likes the environment and the work culture of research, what are some possible, I guess, negative things about industry? Or like, would you recommend doing industry, trying that out first, and then going back into academia? Like, what are your thoughts on that?
Yeah, so in terms of research, I would focus on actually, so the way I approach research is that, academia, you become very valuable if you publish a lot of papers, right? And I think somebody mentioned before that a lot of those papers never see the light of day, they never make it to industry. But I think because the value is in how many papers you can write and how many grants you can get because you wrote a lot of papers, right? The way I approached research in my PhD is that I actually wanted to solve a problem that I saw people were having. So that didn't give me a ton of papers, but it gave me the ability to work on a real problem that people were having and create an actual solution that worked, right? So in terms of industry, I would say I did an internship at Intel, but Intel Research Labs. So I was at Intel Fellow through my PhD. Was it helpful? I mean, they pay better during the summer, so you get to make more money. But other than that, I would say that I would focus on finding something that you love doing. I won't say I can't express that enough. Just find something that you love doing, and you'll be so successful that, yeah.
So I have one follow-up. So
Yeah.
is there a reason why you didn't continue like your path in academia, like after you get a PhD, like postdoc and maybe faculty position at university?
Because I was getting amazing results with the technology, and I was talking to folks from industry and global foundries, and they really encouraged me to do the startup. So once I saw that people in industry, like the people that I knew in industry, were excited about the technology, I saw it as an opportunity to do something meaningful with my life. So I think that's, yeah.
Awesome, thank you. Let's give him another round of applause.
Thank you.
Oh, that was very insightful. Yeah, we're almost there. How many can still take one more semiconductor session? Just one more. Okay. Wow. Yeah, most of us are Aggies. We can handle it. So it's my pleasure to welcome on stage also an Aggie, Clayton, to talk about Texas A&M Semiconductor Institute. Oh, please.
Howdy. You're still here. My name is Clay Hubert. I in Texas A&M class of 2012, and I'm the Director of Workforce Development at the Texas A&M Semiconductor Institute. And we're part of the Texas A&M University system. I'm going to give you a little bit of background on me, just so you know why I'm here, why I do what I do. So I started my career and my adult life really as a reactor technician in the U.S. Navy. They sent me to college, and there was nowhere for me to go except Texas A&M University. So I graduated from here in 2012 and went back into the Navy as a helicopter pilot. I was an instructor pilot. I ran academic programs in schoolhouses, and then I led organizational learning for a couple of organizations within the Navy before coming here. So I'm an outsider, and I love being an outsider. If you listen to the industry panel, they love outsiders too. They love recent graduates, people from outside of the typical disciplines because of what we bring into it. So I welcome you. And I told you that background about me because I always loved working with my hands. I love building things, I love fixing things, I love solving problems. You can work with your hands and solve a lot of problems in the armed helicopter, which is what I did. And I don't think I'm alone in loving working with my hands, building things and solving problems. So I'm truly honored to be in this job right now to help people get educated and trained and employed in fields where they can do that. Semiconductor manufacturing in Texas and the U.S. is a really big deal. That's me, but I want to know about y'all. Undergrads, raise your hands. Rowdy one. Golly. Okay. Graduate, master's candidates, PhD candidates. Cool. Anyone here from the Texas A&M University system, but not Texas A&M University? All right. All right. Anyone from outside of Texas A&M University system? This is awesome. Good deal. Anyone from our nearby community colleges or North Texas community colleges? Okay, cool. Double E majors, let me see. Mechanical engineering majors. ETIG. Chemical engineering. Physics. Construction science. MBAs. MAs. Business school. Okay, one or two. So, help me after this and get the word out. Because as brilliant as the 90% of you who are electrical engineers are, and we all recognize it and acknowledge it, you can't do what you need to do without a lot of support from other folks in the industry, wherever you go. So get the word out about STEM. So what we're going to talk about here on these next only 4 slides, I'll have a lot of time for happy hour, dinner, chili fest, whatever you're doing. There you go. So we're going to talk about why semiconductor manufacturing matters, and that's been covered a few times here, so we're going to cover it really briefly. We're going to talk about what the Texas A&M Semiconductor Institute is, why we're here, what we're doing. We'll talk about where you fit in here within Texas and within the system, and then I'm going to ask some questions for y'all. More questions to ponder, not as much as Q&A. And with that, oh, sorry, I forgot to ask one question for one group. Do I have H-1B visa students in here? So international students, international researchers? Okay, glad y'all are here. Industry can't do it without you, so we are happy that you're here. We're happy to have you. You are valuable, you are important, you are part of this team, so you are welcome. So, as this national policy starts to unfold and the semiconductor industry is growing because of it, national security is part of it, but industry acknowledges just how important exchange and H-1B visa students are in your ability to research and work in industry. So you're part of this team too. But we know that semiconductor manufacturing is important in the U.S. for national security, for technology security, IT, for our supply chains. Remember when you couldn't get an F-150 in 2020 because we're out of microchips? Who knew, right? Y'all got the memo, so now you're here going through the double E program with Texas A&M. And then our economy as well. So in addition to everything else that semiconductors are related to, the semiconductor industry itself is going to be a big part of our economy. It already is. The industry also needs prosperity for you. So anyone, a 2-year graduate who gets a job as a technician in a semiconductor fab is already programmed in the middle class, benefiting their life, changing their family's life, while boosting their regional and state and national economy. It's also prosperous because you saw a slide earlier, Deloitte reported that the U.S. semiconductor industry is going to be worth $1 trillion in 2030. So y'all are just in time. Congratulations. Buy the tin now, get in there, let's go. Another big thing is, it's bigger in Texas here, and so is the state investment in the semiconductor industry. So the Texas semiconductor industry has invested $113.6 billion in the state to build new facilities, new programs, bring in new hires, do more research and more development. The Texas CHIPS Act itself is worth $698 million. And then the Texas A&M University system received $226 million to get involved in semiconductor research, development, and workforce development. And that's where TSI comes in. And what is the Texas A&M Semiconductor Institute? Well, it's a new kid in town, along with space, which makes it popular and makes me write a lot of emails to my bosses about how things are going. We started in May 2023, the month before the Texas CHIPS Act was signed. And our job is to convene. We convene industry, we convene academia, we convene nonprofits, and we convene government agencies all together for the purpose of advancing semiconductor front-end processing, research, development, commercialization, and workforce development. And so we're glad to have Ty here and Texas University here as well, because they're focusing on packaging. So we can work together really closely and collaborate because we're not in direct competition with one another. And we both got big pieces of the Texas CHIPS Act pie, so everybody's happy. So when Dr. Reiner talks about opportunities at Ty and within the Texas system to go be an intern or to go work for them, go do it. Get your degree in the Texas A&M University system and then drive 84 miles down the road to Austin and go work there and learn. If you're into packaging, go do packaging there. And if you're into process, then stay here because it's going to be awesome. A big deal for TSI is nearly future home of the Texas A&M Semiconductor Institute building, which is going to be the newest and most advanced research and education dedicated semiconductor fab in the country. So it's going to go on the Texas A&M Rellis campus. It's going to have, for example, one clean room, ballroom style clean room of 8,800 square feet, along with 14,400 square feet of sub-fab and then support facilities, and then additional dedicated research clean room space too. So it's going to be big, it's going to be awesome, and we look forward to seeing you back there in a couple of years. We're expecting to move in Q1 of 2028. So as far as Texas A&M Semiconductor Institute, where do you fit? Well, it depends on where you are. If you're an undergraduate student right now, or if you're already in industry. So here at the school, we have opportunities for student worker technicians. Are any of the Aggie Fab or 7th floor academic research lab student worker techs in here? Y'all, that's the cheat code. Okay, I know it. I know Samsung's beating down the door for y'all. So blow up Dr. Malhotra or Mr. Atkins' inboxes, and that's the way. If you're an undergrad or a graduate researcher and you get good working in those facilities, industry knows that they are after you. And so one thing we're going to do with the TSI building is we're going to grow those student worker positions along with undergrad research and graduate research together. Good job. Undergraduate research, so we also have undergraduate research experience over the summer. You can get involved there, and great resume booster. We have a new Master's of Science focusing on semiconductor and microelectronic manufacturing starting in fall 2025. So graduating seniors, college station's great, stick around. Sophomores and juniors and freshmen, you get to hear it here first, whoever's left, is this will be available as a 4+1 program. So if you're interested in getting the Master's of Science here from Texas A&M, call the advisors, call your advisor, program directors, professors, and ask how you can go ahead and get involved to do this as a 4+1, because they want you to have this program. They also offer 4 semiconductor certificates. One's available to undergraduates, that's a certificate in semiconductor processing, in addition to safety, microwave design, and digital IC design. TSI wants to help you get industry partnerships, so I bug industry and see what they have available. They bug me and say what they have available, and then you come to us, and we'll try and get you internships that are really going to pave the way for the future of your career. In addition, we're pursuing ways to get non-credit online courses to top up, especially if you come from a program that wasn't specifically related to semiconductors. And in the near future, we're going to have micro-credential courses that are accredited micro-credential courses that can be all learning or hands-on based. More to follow there. So that's why we're here. That's what TSI does. That's where you fit in. And then my questions for you to ponder really are, what can TSI do for you? What can the Texas A&M University system do for you? What's the missing piece? What do you need from where you are now in your seat, whether it's in a classroom or in a lab, to get from there to the semiconductor industry? And that's really it. So I appreciate your time, and I appreciate y'all being here. And that's it.
Any questions? Any question or two?
Hi, it was Jeff. I'm a software electrical engineering student here at Texas A&M. I was just wondering, are there any opportunities for undergraduate students to actually come to TSI or come to student initiative or spreading semiconductor opportunities in Texas?
To answer your question, candidly, not yet. So the team increased, we are a startup as well, which is great. The team increased by 33% at the end of February when they hired me. So now Texas A&M Semiconductor Institute is 4 people. But it's okay because we're doing this with no infrastructure, with both partnerships, and getting through there. So yes, in the near future, there are going to be opportunities for interns involved in facilities, involved in educational programs. So yes, not today. Thanks for your question. And I should let you know, so we got the QR codes up here. Up top takes you to the TSI website, and on the bottom takes you to our LinkedIn page. Please follow the LinkedIn page. We'll post like semi news that's relevant to our little world here in the middle of Texas as often as it comes up. Also kind of just an exchange for ideas and networking. But if you're doing anything regarding semiconductors, if you're going to pursue graduate education, if you're going to pursue internships, careers in semi, I want to know about it. And so any of the methods up here, let me or let TSI know. And if all you do is send an email to TSI at tamu.edu, subject line, I'm in, that's good enough for me. And then we'll go from there. So thanks.
Any more questions?
I just wanted to know if the 4 or the 5-year PSNS program is that for the Texas A&M system or just for Texas A&M students?
So the 4+1 itself is only agreed to within the Department of ECE. So within the system, no one will say no right now. It's worth a talk between your advisors within your university and the advisors here. If you're able to drive, across town, across state to make those classes, there's a possibility. I know it can be tough. So the agreement is within the department. So to answer your question, frankly, no, but it's just possible.
All right, that's all we have for questions. Thank you.
Howdy. Wow, how many of you enjoyed the session today? You guys should clap for yourself. You stay till the end. This is amazing. Yeah, you can clap for yourself. So we're just going to do a wrap up. So I'm going to have the IEEE TAMU president just briefly come and introduce the TAMU important team. Then after that, we're going to have an award session. Then I'm going to have Sharon to do the vote of thanks. So give us just 10 minutes, then we're going to go for dinner. So dinner is ready for guys that stayed until the end. Thank you.
Thank you, Bill. So yeah, as we approach the end of this successful event, I'd like to take a moment to talk about IEEE's involvement here at Texas A&M. Unlike what most people think, we're not limited to a single organization here. We have what I like to call the IEEE ecosystem. So starting off, we have IEEE TAMU, which is like my organization. We serve as the main contact point between the IEEE and IEEE chapters, society chapters here at Texas A&M. So myself, I'm Akshay Mehta, the current president of IEEE TAMU. We also have Stephen, who's our current vice president, Gupta, who's our secretary, and Vijay, who's our treasurer. And I'll hand it off to Oliver, who's going to talk about the upcoming plans for IEEE.
Everybody, I'm really glad y'all stayed to the end. I was just letting you know, we have a lot of people graduating this semester as a part of the whole IEEE board and just the officer team. And so there's a lot of positions opening up for officer applications, which are coming out this weekend. And to the people who are here, the fact that you are here really shows that you're dedicated. So if you are interested in applying, be sure to slip in your application somewhere that you were at the end and you watch you pick the conference that you wanted to join, and I will be sure to get you an interview. just because the fact that you're here says a lot. I'm really excited for the next year. We're really going to try to get integrated with greater IEEE as a whole. I feel like that's something that we've been, I don't know, we haven't been doing as well, but I'm really trying to make ourselves a part of the bigger picture here. If RG wants to come up and talk about her, she is going to be our secretary. Sadly, Seth and Nafi could not make it. They have some stuff to do.
Howdy everyone, I'm Arjun Pathwell and I'll be the incoming secretary for the next year for IEEE TAMU. And just being, so this past year I was actually the junior webmaster, so I actually got to be integrated with all the other roles and I got to see what all the other officers do, and it made me really want to take more initiative and responsibility for the upcoming year, so that's why I decided to run for secretary. And a big vision I have, for me, is more internal. I think at Texas A&M specifically, we can use a lot more collaboration within our students, and I want to combine the internal A&M group with IEEE USA or just IEEE in general, and maybe even with other schools like UT and UNC, because I know we have a lot of dedicated students who are also involved with IEEE there. So I'm so excited for the new year. Thank you.
So yeah, as Oliver mentioned, most of our officers are actually very busy working behind the scenes, getting ready for the dinner and everything. So as I previously mentioned, an integral part of IEEE is the chapters, society chapters. I have with me representatives from IEEE RAS, IEEE CAS, and IEEE MMTS. Let's give them a round of applause for them.
Alright. Howdy. My name is Ron Venegas. I'm the founding chair of the IEEE Microwave Theory and Technology Society at Texas A&M University. And what this new organization is all about is to help students kind of gain competency in microwave and radio frequency theory, technology, and apply it to make their own successes, to distinguish themselves from a GPA and become more than a number. So this implements meeting with our sponsors and getting sponsors related to the microwave field, as well as building new relationships such as Dr. Paris with Torgo, but mainly taking our sponsors with the Running Schwartz, Pathworks, and the Intelligent Electromagnetic Sensory Laboratory to build these projects and these communities of microwave engineers who are trying to start out with a career in the field. So if you want to contact me, if you're a current company or in another university, please reach out. I'm trying to build a Texas-wide kind of microwave and RF society and a community to help individuals break down success. We also have a Instagram account, and you can find that with the QR code. But thanks so much.
Howdy guys. My name is Alan Jeff. I'm an electrical engineering sophomore here at Texas A&M, class 27. And so this is CAS. This is the Circuits and Systems Society. It's the newest addition to IEEE here at Texas A&M. We just incorporated this membership in February, and I want to introduce you guys to it. So CAS, the vision of CAS is to essentialize the knowledge of circuits and systems knowledge to the world, as well as drive sustainable development of circuits and systems. And our mission, the way we accomplish this mission, is through garnering a strong community with social circuits and systems through interdisciplinary individuals and creating a strong group and team for CAS. So what does this kind of look like? This past February, as you can see these two photos, that was my team. Sharon Thomas is my mentor. She was also our team lead for that team in February. And this is our three IEEE Texas A&M teams competing at the CAS competition in February. And our three projects were an RFID-based cat feeder, a bridge health monitor sensor, as well as a hardware faultiness detection using AI. So this is the scope of things that we work with here at CAS. This is the scope of knowledge that we have here at the Circuit Systems Society. So if you feel like you can develop your skills, compete, and meet with like-minded fellows, please, we open you with open arms. Come join the Circuit Systems. Thank you.
You're a national member, it's free, by the way. It's not extra cost. If you're a student, you can join CAS for free.
Howdy. So field, and so I, as a mechatronics graduate, I was like, okay, how can we fix that? So we started the Robotics and Automation Society here at Texas A&M, and we were competing at the NASA Rascal competition. And next year we plan on competing in Lunobotics, where we're creating a lunar maintenance rover to do maintenance tasks for astronauts, such as transporting payloads, connecting wires for them, swapping out sensors, etc. Recently, actually just last weekend, we presented at the AIEEE conference, the American Institute of Aeronautics and Astronautics, and they really liked our design for the rover. You can see the 3D model that we made here. I can get into more specifics when I'm off stage afterwards if you have questions, but it uses autonomous navigation and it has an ML algorithm to fine-tune its PID controls. So we're doing a lot of advanced embedded systems, machine learning, and mechanical engineering on this robot. And in the June, as Ms. Jalen Kelly mentioned, we're actually going to participate in the IEEE Ubiquitous Robotics Conference, where we're going to be presenting this robot. And by then, we should have simulations done for our navigation and object transportation software. So if you have any other questions about this or specifics about how this robot works, I can get into that off stage. Thank you.
Okay, we are at the end. So we are ahead of schedule so that you guys can have some time to talk. The dinner is going to start in about an hour's time. So our time visit our sponsors, our exhibitors. We know the CEOs around and the senior directors around. Yeah.
So without further ado, I'd like to thank all the speakers and panelists and keynote speakers for their time and effort. And so as a vote of thanks, I have a certificate for all of you. So I'm going to call your name off and please come to the stage. You can take a picture and remember this moment forever and ever and ever. So first up, we have Mr. Jason Brown.